Hey guys, so here's part 2 of the 4.5 notes. We are now going to go ahead and solve quadratics by taking the square root on both sides. Okay, let's look at example 1. We have y squared equals 81. Now, whenever we are solving, we need to make sure we get the variable all by itself, and then we can actually solve it, okay? So anything squared, we need to make sure we get that all by itself. So let's look at y squared equals 81. We notice that the variable squared is all by itself. So we can go ahead and get rid of that squared. Now, in order to get rid of that squared, we need to take the square root on both sides. So remember, square root and squared, they cancel each other out. So we get rid of that square, we get y. Now, this is where we just did all that simplifying. 81, is that a perfect square? So either you can have your list up, or you can just plug that into your calculator, okay? Yes, 81 is a perfect square. What is the square root of 81? It is 9. Now, I want us to think about this because we just get 9, right? So we know 9 times 9 equals 81, okay? What about negative 9? So let's say we put negative 9 times negative 9, and you plug that into your calculator. What do you get? You should also get 81. So when we are taking the square root, we don't only just have one answer, but we have two solutions. So in order to represent the two solutions, so the positive 9, so we do 9 times 9, but to also represent the negative 9 times negative 9, we're going to use this symbol. It is going to be the plus minus. Or another way I like to say it is positive negative. It just depends on what the situation. So if you are adding and subtracting, it will be plus minus. If it's just the number itself, then it'll be positive, negative, okay? So here, we need to make sure we have two solutions. And if you think about when we solve by factoring, how many solutions did we usually get? We usually got two solutions. So whenever we're solving quadratics, we will usually get two solutions. So this will be our final answer. Okay, let's look at number 2 here. So once again, we have y squared equals 50, and notice that we do have our variable squared all by itself, okay? Or another way of saying is we got the base squared all by itself. So to get rid of that squared, we have to square root both sides. The square root and square, they cancel each other out, so we get y equals. Now 50, is that a perfect square? No, it is not, okay? So we look at our list, it's not. So let's see what is the largest perfect square that goes into it. So we look at our list here. We kind of want to go to the smallest amount, right? So we kind of would go anything to the right of 49 will be too large. So let's think about 49. Can that go into 50 evenly? No. What about 36? What about 25? Yes. So we do our two branches. We have square root of 25 times, and it's going to be square root of 2. So 25 times 2 gives us our 50. So what's the square root of 25? That is 5. And what's the square root of 2? That is 2. So then here, our final answer is y equals. Now don't forget, we need to have the plus minus sign, right? Because we have two solutions. So our final answer is y equals plus minus 5 squared root of 2, because we need to have two solutions. Okay, go ahead and pause the video and try number 3 for me, please. Okay, let's see what you got here. Now, notice, do we have for number 3 the variable squared all by itself? No, we have the 6 in front of it. So we actually have to get rid of it. And in order to do that, we're going to divide. Because notice this is saying 6 times z squared, and the opposite of multiplication is division. So I get z squared equals, just plug 150 divided by 6 into your calculator, and you should get 25. Now, we can take the square root on both sides because we have the base squared all by itself, or variable squared. The square root and square cancel each other out. Now, 25, is that a perfect square? Yes, it is. So we have z equals, don't forget the plus minus, and then we have 5. So remember, we have two solutions. We have the positive 5 times 5, which gives us 25, but we also have the negative negative 5 times negative 5 to give us positive 25. Okay, go ahead and try number 4 on your own as well. So pause the video and do that. Okay, let's see what you got here. So in this case, do we have our base or variable squared by itself? No, we have x squared minus 6. So we actually have to get rid of that 6. So what we would do is add 6 to both sides. So we get x squared equals 4. And now that we get our base squared all by itself, I take the square root. So I get x equals, is 4 a perfect square? Yes. So now I have plus minus 2. And that would be my answer. Okay, now let's look at the next one. This one looks a little bit different than from 1 through 4. So we have 3 times p minus 1 squared equals 15. Now notice our variables inside parentheses and that's squared. So this is why I'm saying base, because you could have something else with that variable inside parentheses, and we have to get that all by itself. So in this case, we actually have to get the p minus 1 squared all by itself first, and then we can take the square root on both sides. So in order to do this, we notice we have a 3 in front of it. We're going to divide both sides by 3. So now I have p minus 1 squared equals 5. So now that what I call is the base, so p minus 1 is what is called the base. Since that is all by itself, we can take the square root on both sides. So the square root cancel, we get p minus 1. Is 5 a perfect square? No. Is there a perfect square other than one that goes into it? No. So we will just leave it as, please don't forget the plus minus. You still need to have that. Plus minus square root of 5. Now, did we get our variable all by itself and solve for? No, not exactly. We notice we have this minus 1. We actually have to move it in order to get p by itself. And so to do that, I'm going to add 1 to both sides. Now, when I do that, I cannot add the 1 to the square root of 5, meaning I can't do 5 plus 1 to give me 6. The reason being is that the 5 is underneath the radical and the 1 is not. So how we're going to write this is I'm going to do that plus 1 in front of the plus minus, and then I have my square root of 5. So really my two solutions here are going to be 1 plus square root of 5 and 1 minus square root of 5. But we can combine it just as 1 plus or minus square root of 5. So that's going to be our final answer. Okay, now let's go ahead, let's do 6. I would like you guys to go ahead and pause the video and try this on your own. Okay, let's see what you got here. Okay, so notice, once again, we have our variable, and it's inside the parentheses on number 6. So what we need to do is get this x minus 3 squared all by itself. Now, this is our basically order of operations here. Remember, whenever we are solving like a multi-step equation, we actually add or subtract first, and then divide or multiply. So our very first step is we're going to add 4 to both sides. So I get 2 times x minus 3 squared equals 12. Now I'm going to divide both sides by 2. So now I get x minus 3 squared equals 6. And now that I got my base squared all by itself, so the x minus 3 all by itself, I can take the square root. So I get x minus 3 equals, is 6 a perfect square? No. Is there a perfect square that goes into 6? Not really. So just like we did on number 5, I'm going to have plus minus square root of 6. Now I still need to move the 3 over. So what I'm going to do is I'm going to put it in front of the plus minus. And I'm adding it to both sides. So now I have positive 3 plus minus square root of 6. And this would be my final answer. Okay, make sure that you, if you have any questions, you contact me. And then make sure you work on the homework. Okay, see you guys later.